With this background about human memory and inference capacities under our belt, let's turn our attention now to particular kinds of inferences, to native human abilities, and to the underlying features that differentiate those inferences. So we'll start off by looking at deduction. We'll note that deduction has the virtue of preserving truth, essentially preserving truth at all costs. A good deductive argument is an argument where if the premises are true, the conclusion also has to be true. A good deductive inference has that same relationship. The initial information is correct. The good deductive inference will result in a transformation where the information made explicit and available is true. For this reason, deduction is non-amplitive as an inference strategy. It doesn't increase the things that have to be true given what we know. It merely takes things that are inexplicit but guaranteed to be true given what we know and makes them explicit. When we look at human beings' ability to evaluate and formulate deductive arguments, we see that our native capacity tends to be highly contextualized. And we'll talk about all the different ways in which deductive inferences are affected by content and context. Formal deductive logics represent an alternative to this in that they make the underlying structure, the logical form of the argument, explicit, separating it out from the content so that we can evaluate the underlying structure independently of the cognitive biases. Formal systems, therefore, represent logical form explicitly. They introduce effective decision procedures to mechanize evaluation. And the price that we pay for this is that we have to come up with heuristics for translating the complicated and variable world and language that we use into these simple and easy to use logical systems for the purposes of increased power for those systems. So if we think about deductive inference, let's imagine the set of all things that have to be true given what a particular reasoner knows. This circle here, the total truths. Within that set of total truths, there are truths that are explicit and available to the reasoner at any given moment. Those are things that the reasoner knows to be true, as it were. There are other things that are inexplicit and or unavailable to them, things that have to be true given what they know, but they don't see or have access to being true. Deductive inferences, then, are information transformations that take that explicit and available information that has to be true for the reasoner and transform it to render that formerly inexplicit and unavailable truth explicit and available. So good deductive arguments as well as good deductive inferences are such that if the initial information is true, the argument is good, it necessitates the truth of the conclusion. So they put the premium on truth preservation. And as a result of that, they trade off inferential power. So deductive inferences preserve truth. Now, some people think that this makes deductive inferences uninteresting. It makes them non-amplitive, but it doesn't make them uninteresting. Deductive inferences will only reveal what must be true given the truth of the premises or given the truth of our initial information. In one sense, then, they really don't increase our stock of truths. But in another sense, they really do, because they make truths that were not explicit and available to us explicit and available. Thus, deductive inferences only reveal what must be true given the truth of our premises. And as such, they're non-amplitive inference strategies. But nevertheless, revealing what has to be true given what we know can oftentimes be revelatory and important. When philosophers, mathematicians, logicians began to study deductive arguments, they came to realize that deductive arguments have two components, that any good deductive argument has these two elements. On the one hand, it has the logical form, the underlying abstract relationships, the structure between the content elements. And on the other hand, they have that logical form. And we talked about the relationship a number of times. Logical form is sort of like the underlying frame of your house. The content is sort of like the facade. Logical form is like the system of roads that get you from point A to B. The content is like the cars that you travel on the roads with. And this relationship between content and form means in order to really evaluate deductive arguments, in order to really formulate deductive arguments, you have to be sensitive to both the underlying structure and to the content of the argument. Does it have true premises? Does it have a logical structure such that if the premises are true, the conclusion has to be true as well? However, native human deductive reasoning is heavily contextualized. It's strongly influenced by content and is relatively insensitive to underlying logical form. Underlying structural relationships and arguments are pretty opaque. Thus, humans make systematic errors when the content and the context of the argument runs orthogonal to its context-free abstract logical form. We saw this come out in many different ways. But let's go back a second and think about why it is that human beings would have this native deductive reasoning disposition. Now, when we think about it, right, given the nature and the existence of humans and proto-humans for that 4.4 to 7 million years, we're talking about hand-to-mouth existence, spending 1,000 calories to get 1,000 calories. The environment is remaining stable, it's relatively homogeneous during their relatively short individual lifetimes. And so their inferences are largely reactions to specific problems at hand. No proto-human is worried about investing money in their 401k for retirement. They're probably not worried about things that are going to happen 3 days from now. So their inferences need to work for the specific content, the specific problem that they're faced with, and the specific content, the situation in which that problem confronts them. And this pretty much limits hunter-gatherer problem solving to largely reactive, relatively simple, and concrete problem solving that's linked to specific contents and specific contents. And so it doesn't turn out to be very surprising at all that when we look at human native ability to make deductive inferences, we find that it's strongly driven by content and context, i.e. it's highly contextualized. And so this combination of highly contextualized reasoning together with limited working memory capacities has huge implications for human native ability to do deductive reasoning problems, either to evaluate them or to formulate them, as we'll see in the next section.